Hello everyone. So we're supposed to talk about today about a topic from our first or second year. I thought if I would talk about that, most of you will be know it, and we want to learn something new. So today I will discuss a mathematical concept that all of us know and some of us use daily, and try to get inside of it and understand it in a new way and try to visualize it. Okay, so the mathematical concept is the determinant of a matrix, and I'm gonna explain it by trying to make you visualize the geometry and take the geometric explanation. And after that, after we are comfortable of the concept and understand what determinant is, I will show you just briefly how to go from this geometric understanding to the analytical formula. And finally, I'm gonna just introduce briefly the concept of rank of a matrix. Okay, so let's get started. So first, I want to talk about a new concept of or a new way of thinking of a matrix. So I want to think of a matrix. I'm talking here of a matrix of a square matrix that has the same number of columns, the same as rows. All right, rows have the same number of columns. So in that way, we think of a matrix as a transformation from one coordinate system to another. All right, so through this explanation, I will take about 2 dimension as to show you what I'm talking about. So here we have a conventional coordinate system, x and y perpendicular. We call them I hat and j hat. And here we have moved to another coordinate system. All right. This is my new I hat and this is my new j hat. And because we are in 2 dimension, we can explain any other vector just in terms of I and j. So if I explain what will happen to j, to I hat and j hat, then I will explain what will happen to any other vector. So to describe that transformation, I just need to describe I hat and j hat. And that's why having this transformation, I need 2 by 2 matrix. The first column is 2 value column, describe what will happen to I hat in terms of the old system, and the second is for the j hat. So here, that's the concept. So what the determinant is? The determinant for a matrix, it's just a concept for the square matrix, all right? So it tells us in that transformation, or any transformation in that sense. It might be in 3D, it might be for 4D, or in 2D, or but other direction, other matrix, which is other transformation. It tells me what will happen to the unit area, or in 3-dimension unit volume, 4-dimension unit, 4-dimensional volume, and so on. What will happen to a unit of that dimensional here 2-dimensional area? What will happen to it in that transformation? It might squished and squished, stretch and squished in both direction, or in one direction and the other. In either case, it might not change, and it might. That's what determinant is, right? Notice that. Okay, I'll just make I'll give you a new insight of how does that work. All right. So here you can go from this geometric explanation to analytical solution. That's usually, yeah, we want to calculate the area of the new, which is yellow area, in terms of the 4 values of a matrix A, B, C, D. Okay. And here's the another just conventional transformation. So let's get back. All right. Okay. So okay. So here the determinant, when the determinant is 0, that means both my direction are aligned, are on the bit. They could be both on 0, or one of them of 0, or both of them are aligned in the same line. Here I lost a dimension. There's a dimension lost in that, right? So when the determinant of 0, I lost a dimension. I might use more than one dimension. So if I went from two-dimensional space to one-dimensional space, the determinant is 0. From two-dimensional space to zero dimension, just a point, the determinant is also 0. Three-dimension to two-dimension, the determinant is 0. All right. So here I want just to explain what the rank is. If the determinant is not 0, the rank is always the same as the size of the matrix. So the size of the matrix is 3 by 3, so the rank is 3 if the determinant is not 0. If the determinant is 0, the rank could be 2 because we could lose a dimension, or it could be 1 or 0. What does that mean? That means some of those three vectors are linearly dependent. That means they are pointing in the same direction or in opposite direction, but they are on the same line. So I lost a dimension. And that's pretty much it. We explained what determinant is. I hope this geometric explanation help you to think of it in a better way, and thank you.